In this video, we're going to talk about how to solve first-order linear differential equations. Now, the first thing you need to do is you need to write it in standard form, and that is y prime plus p of x times y, which is equal to q of x. Now, once you have it in standard form, you need to identify the functions p of x and q of x. Now, the next thing you need to do is determine the integrating factor, which is e raised to the integral of px dx. Now, once you have the integrating factor, you can now write the general solution to the differential equation. So it's going to be 1 divided by the integrating factor times the integral of I of x times q of x dx, and then plus some constant of integration. Now, once you integrate this portion to get the integrating factor, don't add the constant of integration. You should only add it at the very end in this step. So keep that in mind. Now let's work on some problems. So let's say if we have this differential equation, y prime plus 2y is equal to 2e to the x. So notice that this equation is already in standard form. So if we write y prime plus px times y, which is equal to qx, we can see that px is equal to the stuff in front of the y, which is 2, and qx is just 2e to the x. So that's the second step to identify p of x and q of x. Now let's determine the integrating factor, ix. So that's e raised to the integral p of x dx. So that's going to be e times the integral of 2 dx. The antiderivative of 2 dx is 2x. And so this is I of x. So now we can write the general equation, the general solution to the differential equation, using this formula. So it's going to be 1 over e to the 2x times the integral of e to the 2x, and then q is 2 e to the x dx, and then plus c. Now let's simplify the expression that we have before we integrate it. So e to the 2x times e to the x, what is that equal to? So we need to add 2x plus 1x, which is 3x. So right now we have this expression. We can move the 2 to the front. So this is going to be 2 times the integral of e to the 3x dx plus the constant of integration. Now the antiderivative of e to the 3x is e to the 3x divided by 3. So now let's distribute this to both terms. So we're going to have 2 over 3 times e to the 3x divided by e to the 2x, and then plus, if we multiply these two, c divided by e to the 2x. So when you divide by two things with a common base, you need to subtract the exponents. So 3x minus 2x is 1x, or simply x. So we can say y is 2 over 3 times e to the x. And then e to the 2x, we can move it from the bottom to the top. So this is going to be plus c e to the negative 2x. And this is the final answer. Now let's work on another problem. X y prime plus 4y is equal to 2x cubed. So go ahead and find the solution to this differential equation. Now we need to put it in standard form. So therefore there should be nothing but a 1 in front of y prime. So we're going to have to divide everything by x to put it in standard form. So we're going to have y prime plus 4 over x times y, and that's equal to 2x squared. So now it's in standard form. Y prime plus p of x y, which is equal to q of x. So we can see that p of x is 4 divided by x. So let's write that somewhere on the side. And q of x, we can see that's 2x squared. So now let's determine the integrating factor. So it's going to be e raised to the integral of p of x dx. So that's e integral 4 over x dx, which is e. We can move the 4 to the front, and then we have the integral of 1 over x dx. The integral of 1 over x, we know it's ln x. Now let's take the 4 and move it to the exponent of x. So this becomes e raised to the ln x to the 4th power. And the base of the natural log function is e. These two will cancel, ultimately giving you x to the 4th. So that's the integrating factor. So now let's use this equation. Y is equal to 1 over the integrating factor times the integral of ix qx dx plus c. So this is going to be 1 over x to the 4th times the integral of x to the 4th. Q of x is 2x squared, and then dx plus c. So let's move the 2 to the front. And x to the 4th times x squared, that's going to be x to the 6th power. Now the antiderivative of x to the 6 is going to be x to the 7 over 7. Now finally, let's distribute 1 over x to the 4th. So it's going to be 2x to the 7 divided by 7x to the 4th, and then plus c over x to the 4th. So 7 minus 4 is 3. So the final answer is going to be y is equal to 2 over 7 x cubed plus c over x to the 4th. Now, how can we check our answer to make sure that it's correct? What we need to do is plug it in back to the original equation to see if both sides are equal to each other. So let's go ahead and do that. But first, let's determine what y prime is. So y, if you rewrite it, it's 2 over 7 x cubed plus c x to the negative 4th. So the first derivative of that function is going to be 2 over 7 times 3x squared plus c, using the power rule, it's going to be negative 4x to the negative 5. Negative 4 minus 1 is negative 5. And so you can rewrite that as 6x squared over 7 minus 4c divided by x to the 5th power. So let's go ahead and plug in y prime, and at the same time, let's plug in y to see if we do indeed have the solution to this differential equation. So it's going to be x times 6x squared divided by 7 minus 4c divided by x to the 5th power, and then plus 4y, so 4 times 2 over 7 x cubed, and I'm running out of space, so let me just get rid of this stuff, plus c divided by x to the 4th, and all of that should equal 2x cubed. So let's begin by distributing x. So it's going to be 6x cubed over 7 minus 4c. Now x divided by x to the 5th, that's 1 minus 5, which is negative 4. So there's going to be 4 x variables on the bottom. And then 4 times 2 over 7, that's going to be 8 over 7. So 8x cubed over 7. And then plus 4c divided by x to the 4th. So notice that these two terms will cancel. Negative 4 plus 4 adds up to 0. and then these two are like terms, so we can add them. 6 plus 8 is 14. And 14 divided by 2 is 2. So because the equations, the left side and right side, are the same, this is indeed the solution to the differential equation. Now let's move on to our next example. So let's say if we have x minus 2 times y prime plus y, and let's say that's equal to x squared minus 4. So feel free to take a minute, pause the video, and try this example. So once again, we need to have a 1 in front of y prime. So let's divide every term by x minus 2. So these will cancel, and we're going to have y prime plus 1 divided by x minus 2 times y. Now x squared minus 4, you can factor it using the difference of perfect squares. So it's x plus 2 times x minus 2. And therefore we could cancel the x minus 2 term. So the equation in standard form is as follows. So we could see that p of x is 1 over x minus 2, and q of x is x plus 2. So let's write that. So p of x is this equation, and q of x is x plus 2. Now let's determine the integrating factor. So I of x, as always, is going to be e raised to the integral of p of x dx. And so that's going to be the integral of 1 over x minus 2 dx. Now the antiderivative of 1 over x minus 2, that's going to be the natural log of x minus 2. So e raised to the ln x minus 2 is simply x minus 2. So this is the integrating factor. So now we can move on to our final equation. So y is 1 over the integrating factor times the integral of ix qx dx plus c. And so that's going to be 1 over x minus 2 times the integral of x minus 2, and qx, we said it was x plus 2 dx, and then plus c. Now, if we FOIL x minus 2 and x plus 2, that's going to give us x squared minus 4. And now the antiderivative of x squared, that's x cubed over 3, and the antiderivative of 4 is 4x. So this is the final answer. That's the solution to the differential equation. Now let's move on to our next example. So let's say if we have 4y minus 3x times dx plus 5x dy, and this is equal to 0. If it's in this form, how can we solve the differential equation? So we need to put it in standard form. And to do that, we need to get y prime. So we have dx and dy. Now keep in mind, y prime is dy divided by x. So that implies that we need to divide everything by dx. On the left side, these will cancel. And so we're just going to have 4y minus 3x, and then plus 5x. And here we have dy divided by dx, so we can replace that with y prime. And 0 divided by dx is just 0. Now, to put it in standard form, we need qx to be on this side. So therefore, I'm going to move the negative 3x to that side. And I'm going to write this term first because it has the y prime. So we have 5x y prime plus 4y is equal to 3x. Now this form looks more familiar. However, we need to make this a 1. So we need to divide every term by 5x. So we're going to have y prime plus 4 over 5x times y, and then that's going to equal 3 divided by 5. Now it's in standard form. So we can see that px is 4 over 5x, and then qx is a constant, and that's 3 divided by 5. So now let's determine the integrating factor. So that's going to be e raised to the integral of px dx. And so px is 4 over 5x. So let's move the constant to the front of the integral. And so we need to integrate 1 over x dx, which we know that's going to be the natural log of x. And so now we need to move the 4 over 5 to the exponent of x. So this is going to be e raised to the ln x to the 4 over 5 power. So this whole thing will simplify to 4 over 5, based on the previous examples that we saw. Well, not just 4 over 5, but I'm forgetting the x. It's going to be x to the 4/5 power. That would have been a serious mistake. So that's the integrating factor. So now we could find a general solution. So it's going to be 1 divided by I of x, which is x to the 4 over 5, and then times the integral of I of x times q over x, which is 3 over 5, dx plus c. So let's begin by moving the constant to the front. And then we could find the integral of x to the 4 over 5 using the power rule. So we're going to have to add 1 to 4 over 5. 4 over 5 plus 1 is the same as 4 over 5 plus 5 over 5, which is going to be 9 over 5. And then you need to divide that by 9 over 5, or multiply by the reciprocal, which is 5 over 9. So we can cancel a 5, and then 3 over 9 reduces to 1/3. So distributing this to everything, we're going to have x raised to the 9 over 5 over 3x 4/5. And then distributing this to c, that's going to be plus c over x to the 4/5. 9 over 5 minus 4 over 5 is 5 divided by 5, which is 1. So this becomes x over 3, or we could say 1/3 x. Now if you want to, you can move this to the top. And so you could say it's plus c times x raised to the negative 4 over 5. So this is the final answer. Now let's move on to our last question. So let's say if we have dy divided by dx, and it's equal to x squared minus y divided by x. What do we need to do in order to solve this differential equation? We need to cross multiply. So first we have x times dy, and that's equal to x squared minus y dx. Now we need to get dy over dx, so let's divide both sides by dx. And then we can replace dy over dx with y prime. So we have x, y prime is equal to x squared minus y. Now let's add y to both sides. So it's going to be x, y prime plus y, and that's equal to x squared. So now we have it in a form that's more familiar to what we've been working with. So we need to make this a 1. Let's divide everything by x. And so now we have it in standard form. Y prime plus 1 over x times y is equal to x. So we can see that p of x is 1 over x, and q of x is equal to x. So now let's determine the integrating factor, which is e raised to the integral p of x dx. So p of x is 1 over x, and the antiderivative of 1 over x is ln x, and e to the ln x is simply x. So this is the integrating factor, and so y is going to be 1 over the integrating factor, and then times the integral of I of x, which is x, times q of x, which is also x, dx plus c. Now x times x, that's going to be x squared. And the antiderivative of x squared is going to be x cubed over 3. So if we distribute 1 over x, this is going to be the final answer. It's going to be 1/3, and then x cubed over x is x squared, plus c over x. Or you could write that as c times x to the minus 1. And that's the final answer for this problem. So now you're familiar with the process of solving first order linear differential equations. And I recommend getting more practice with your textbook if this is not enough. So you can try out harder problems, but the process of solving it will still be the same.